Hello, today we are solving a VVD problem, and let's look at the following problem. A fisherman spins the fishing reel on his fishing rod at a speed of 3 revolutions per second. Yeah. If the radius of the spool is 3.7 centimeters, what is the linear velocity of the fishing line as it spools? How will the answer to the question change if the radius of the spool is doubled? Let's write down the problem statement. So, we will need to determine the linear velocity of the fishing line when winding. We will denote this velocity as v. Given that we have a second question about the changed velocity, so we have v1 and v2. What do you and I know here? We know that the coil is rotating at a rate of 3 revolutions per second. What is that? So we have a certain number of revolutions. 3? Yes, and there's a certain amount of time that it takes the revolutions are made. We also know the radius of the coil. It's 3.7 tenths of a centimeter. And that's it. And then we know that R2, let's see, R1 would be the initial radius, and then we're looking at a situation with, say, twice the radius of the coil. We look at the data and we can see that the radius here is not in system units, so we can already convert the radius of the coil into meters. But now let's remember the formula for determining the linear velocity of rotation of an object, or a point on an object, because what we have here, we can have a body rotating, a small body on a circle, or we can have an object with some dimensions rotating, and then we can consider different points on this object. And then we can look at different points on that object. The coil would be one of those objects. So it has certain dimensions. So let's say this is what the coil looks like. And this is where the handle might be. And then, for example, this is how we have the line is stretched. And in this case, rotating this spool, the fisherman will wind the line on it. In this case, in order for the line to move this way at a speed of v, the spool must be spinning in that direction. What do we need to know in order to calculate the velocity v? Well, first of all, you and I need to understand that the line is moving along the furthest dimension of the circle So the radius of the spool in this case is just the radius of the spool. This distance of the fishing line relative to the axis of rotation will be r1. And there is a certain speed with which this spool will rotate. Let's denote this speed by the letter omega. But how are all the parameters that we have indicated in the figure related to each other? Well, in this case, we have a formula that defines the relationship between the velocity of the body, that is the linear velocity of the body, or the points of this body, as we say here are the extreme points, with the angular velocity of this rotation, and the radius of distance of this point from the axis of rotation. So you and I know this formula, but the only point is that we don't know what the angular velocity of rotation of this coil is equal to. And to do that, you and I realize that we have a clue. That is, we realize that the coil is rotating at a certain speed, which is 3 revolutions per second. And for that, we have a special value that we call speed. It's defined as the ratio of the number of revolutions to the time over which those revolutions were made. Well, and now our task is to remember how the angular velocity and other rotational parameters, such as frequency or period, for example, are related, if it is necessary to connect it. So there is a formula that defines the relationship between angular velocity and the period of rotation of this object. The formula looks like this, or if you and I remember that. The period is the reciprocal of the frequency. Then we have the following notation. I will write down for now in the form of a 3 decimal fraction, that is, we have replaced the period. But if we replace division by the fraction and multiplication by the fraction, then we get the following formula. The angular velocity with frequency related directly proportional to the coefficient, the proportionality being 2p. And now we can try to put together the final formula for the calculation. The velocity then comes out to be a 2p times the frequency and multiplied by the radius of the first coil. The formula is ready. Let's do the calculation. we have p directly equal to 3.14. The frequency is equal to this. 3 divided by 1 is 3 revolutions per second, and the radius of the coil is 3 whole 7/10 of a tenth minus 2. We put all the data in SI, so the dimension here is meters per second. And we get a velocity of about 0.7 meters per second. Also, that's the speed at which the line will be spooled onto this reel. And as for the second question, how the speed will change if the spool will have twice the radius. If you and I look at the formula carefully, we can see that at the same speed. The speed is proportional to the radius of the circle and therefore to the coil. So, since the radius has doubled according to the problem, we can say that the speed will also double. So it's going to be about 1.4 tenths of a meter per second. That is, by the example of this problem, we are once again convinced that the rotational motion is most convenient to describe, of course, the angular parameters because they are common to the whole rotating body. Linear parameters will depend on how far the given point is removed from the axis of rotation. So that's the end of the task. We'll see you in our next lessons. Goodbye.